Cauchy's integral formula to evaluate this integral, where C is a circle mod z equal to 2, right? So this is the integrand given to us with this circle. What are the singular points for this? Now to find the singular points, the points where this function is not defined. So for that, we need to put the denominator to be equal to 0, and we get z plus 1 equal to 0 and z equal to negative 1. Now check whether this point lies inside the circle or not. Yes, the circle is having the radius 2, and yes, z equal to negative 1 lies inside the circle, right? So now we need to use the Cauchy's integral formula for this point. So the integrand has a singularity at z equal to negative 1, which lies within the circle mod z equal to 2. Now we have to take this numerator to be our f of z, which is analytic inside this circle. So taking f of z to be equal to e the power 2z, that is analytic inside this circle, also on this circle, analytic inside and on this circle, the circle mod z equal to 2. Very fine. Okay. Now applying the Cauchy's integral formula. So by Cauchy's integral formula, for the higher derivatives, the given integral e the power 2z divided by z plus 1 the power 4. This is equal to, what is the formula for that? What is the formula for the higher derivatives? The closed integral over the curve C on the integrand f of z divided by z minus z naught the power n plus 1 dz is equal to 2 pi iota into the nth derivative at z naught divided by n factorial. Please remember, if you are having here n plus 1, then you have to take the nth derivative, right? I'm having here 4 and here I'm having n plus 1. So what is n? If n plus 1 is equal to 4, then n is equal to 3, right? And what is z naught? It is negative 1. I can write this as z minus minus 1. So z naught is negative 1. Very fine. Okay. So this is equal to 2 pi iota into the nth derivative. N is 3. That means we have to take the third derivative at z naught. Z naught is negative 1. Divided by n factorial, that is 3 factorial. Now what is f of z? That is the numerator, this one. So this is e the power 2z. What is the first derivative for this? It is e the power 2z into 2. And the second derivative? It is 2 into 2 e the power 2z. Third derivative? It is 2 into 2 into 2 e the power 2z. Is it fine? Okay. So this is equal to 2 pi iota. Writing the third derivative of f at z equal to negative 1. So from here, if I put z equal to negative 1, I get this to be as 8 into e the power 2 into negative 1. That is equal to 8 into e the power minus 2. So this is 8 into e the power minus 2 divided by 3 factorial is 6. So cancelling this with 2, and we are getting this to be 8 pi iota divided by 3e square. So this is a required answer for the given integral. Okay, thank you. Stay blessed.